Hi, everyone. So the thing that I really want us to maybe think about is what our industry is doing at a high level. At a high level, I think our industry is part of a larger tradition of creating the truth. So historically, there have been different versions of the truth. One version has been mythical truth, which is the first type of truth that people created for each other to make them feel safe, so that they can predict the world and make it reliable. But most of the time, all these different truths, they create a more reliable world. So the mythical truth of stories and myths was, really the first truth that we're all very familiar with. Then you had the appearance of what I consider to be measurable truth, and you could navigate and you could build buildings and some first early versions of mathematics. And the benefit of that was measurable truth, and you could measure things, and in that sense you could know things and understand the world and be in a reliable world. The next version of truth that we've all greatly benefited from, even though the clicker doesn't seem to work right now, is computational truth, right? So you can compute things in larger and larger amounts, and that represents another type of truth that makes the world work in a new and better way. I think that all of our collective work in this industry is part of creating cryptographic truth. So cryptographic truth for me is something that appeared only in the last decade or so, and allows the world to be a much more reliable place because we can deterministically relate to each other. Before cryptographic truth, next slide. Before cryptographic truth, we could only relate to each other in a probabilistic way, right? So there's a brand that says it's going to do something, and it may or may not do it, and that brand manages our relationship with each other and with that institution. And so now we basically need to trust the brand. And it doesn't matter what the brand is. It could be a big entity, it could be a government entity, it could be any other entity. But the trust in that entity, in that brand, is the basis of our relationship, right? Now we have a technical way to deterministically guarantee our relationship about everything. About transactions, value, information, everything, at least in our digital life. And this is a very big shift. This is fundamentally the shift that I feel we're all a part of, and the shift that we're working on from a technical point of view. So far, we've made this shift happen for about $8.5 trillion in transaction value, which is the amount of value that's been processed through Chainlink Oracle networks. We've done that by providing almost 10 billion different data points, and all of those data points were generated in a cryptographically truth-preserving way, right? So we put a bunch of cryptographic truth into blockchains, which are another type of cryptographic truth system, and then that got combined to create huge amounts of value, often known as DeFi. And so that's what's happened so far. Now, just to understand a little more about what I mean in more detail, if you look at applications that people are trying to build in our industry, they have a recurring pattern of how they don't work. So they don't work because even if the blockchain works, some system connected to the blockchain doesn't work. The data gets manipulated. The bridge gets manipulated. The automation or key holding server gets manipulated. And so while we all seem to have a real affinity and interest in deterministic, highly reliable systems, so much so that if you give us a blockchain, we get really excited, unfortunately, historically, we haven't been able to make a fully trust-minimized application until relatively recently, with our work, providing a reliable source of inputs, right? So the first thing that we did is we made data highly reliable, and making data highly reliable and decentralized is what allowed DeFi to grow into what it is today. Because when we launched Oracle Networks, which we originated, DeFi was sub 100 million. And then it grew to over 200 billion, and now it's less. But basically, the catalyst for DeFi, for a financial product, was market data. And so that's what we facilitated through Oracle Networks. The next thing we facilitated was computation through things like automation. And when you combine decentralized data and decentralized computation, you get much more reliable applications, which once again is a huge improvement. And now the final problem that we've recently launched a solution for is cross-chain in the most decentralized secure cross-chain system there is, so that you can consume data, do reliable computation, and access value on various chains, all in a reliable way that creates the inputs into smart contracts to make them truly reliable advanced applications, which essentially creates more advanced cryptographic truth, which is what we're seeking to do. This is a general overview of what we work on. So there's the data side, there's the compute side, and then there is the cross-chain side. The data side is what we're best known for because we power the vast majority of data in the decentralized world. The compute side is what we're known for in the gaming industry for things like randomness, like the VRF random number generation service. But then there are many other forms of compute, automation, and soon functions, which once again allow reliable, cryptographically guaranteed agreements by injecting more cryptographic truth into the system. And most recently, we've launched cross-chain. And I'm kind of really here in Singapore and soon Hong Kong and Korea, really to interact and work with some of the best users here and the banks and all the different folks, because I really do see that this region is on the cutting edge of building the more advanced applications. And so we really want to support that and be a part of that. This is our cross-chain system, which was launched over a month ago, and it's a good example for us to understand what makes a secure, decentralized service. So there's basically, at a high level, 4 levels of making a service. Level 1 is you make a server, a single server, you make a web page, and you call it a service. That's not really secure or scalable. Then if level 1 is also, somebody asks you how is it decentralized, you make a second server that you also control, and you put on your web page that it's decentralized. That doesn't work, because it's not decentralized, and if someone gets access to 1 or 2 of those servers or those keys, then they own the service, and then they own all the contracts connected to the service. So you really don't want to be dealing with anything at the first level. Examples of this are things like multi-chain, where a single laptop can control an entire service. Not good. Level 2 is where you go and you make one network, one validator set, through which all value passes. That is better because you at least have multiple separate nodes, but it isn't scalable, because you're never going to process everything through one network. If we were going to process everything through one network, we would do it through one blockchain. But we can't, because it can't. And that's why we now make app chains, because blockchains can't handle it. Likewise, any one service powering everything through just one network won't be able to handle it. The third level is when you can make multiple separate networks for specific purposes. That's what Chainlink has been doing for years and has originated over 1,000 Oracle networks. And if you think about that, that's actually a certain dimension of scalability, where if you look at other systems like app chain systems and frameworks, they've only been able to make 5 or 10 copies of themselves on production to secure value, while Chainlink has been able to make over 1,000 replicas. And then the fourth level is what you see here. It's when you have multiple networks and you have something called risk management. So risk management is this really interesting idea that avoids horrible failures, like the ones we've been having with all the big failures that make our industry look bad when it loses tens of billions of dollars. At the fourth level, you have risk management. So what risk management does, and in this example, you have the main Oracle networks doing the transactions, and then you have the risk management network. And if you think about any system that moves around value, whether it's a payment system or a credit card system or a bank system, they always have some notion of risk management, right? Risk management departments, risk management software, so on and so on. So the thing that we've done up to this point is make multiple networks, decentralized networks where we don't run a node, and now also a risk management system to make it so that the Oracle networks can avoid various risks. I'll give you an example of a risk you want to avoid in data. So let's say a big exchange like FTX goes down, and then you have 10 data sources that some of which use FTX heavily and some of which don't. You want a system that automatically removes the data sources that are heavily weighted towards FTX and replaces them with data sources not weighted toward FTX. And this way you can continue to give accurate price data and you can allow DeFi to function correctly. So that's a good example from risk management, for risk management in data. In cross-chain, which is, by the way, where our risk management experience also comes from, it's that there's like about 50 different things that can go wrong that you can't predict when you use a decentralized system, like an Oracle network. In cross-chain, risk management really comes to defining whether a transaction is safe or unsafe. So for example, do we want to send $600 million to some new address on some new chain we've never ever sent anything to? Maybe you could set your risk management parameters to allow that, or you could set them to say, you know, we probably need a second check on that before we do that. Might be a good idea, maybe. And that second check could avoid, like you need a second multi-sig or a second approval from the user or whatever. And that second check can avoid a $600 million bridge hack. It's like a very simple idea, right? Risk management. So this is the additional final feature of CCIP in addition to decentralization. Other bridges that you see are really at level 1 or 2. None of them have made multiple networks that are secure at scale and reliable. And then no one, as far as I know, has risk management. So it's really decentralized, secure systems that you can make hundreds, thousands, and eventually hundreds of thousands of replicas of to make hundreds of thousands of services. And then those services have a dimension of risk management, which allows the system to continue functioning through all kinds of exogenous events, external events that you have no control over. What we are very excited to see is what we call the Internet of Contracts for advanced smart contracts. So the world that we're really working towards is a hyper-connected world with lots of blockchains interacting with each other. And those blockchains and those contracts, while interacting with each other in a secure, reliable, risk-managed way, can interact with external systems like data, random numbers, compute, AI, weather, identity, whatever you want, frankly. You should really be able to build a Web3 system or a Web3 product like you build a Web2 product. And also, by the way, it shouldn't matter what chain you're on. Because like when you use Uber, you don't know what cloud Uber runs on. You don't care. You probably couldn't even find out, frankly. It doesn't matter. Like what you care about is that the application does something for you, right? So the world that we need to get to is a world where all the chains and all the external systems can work together in a secure, efficient, reliable way. And then we can have the Internet of Contracts. Now, the Internet of Contracts will actually take two forms. There will initially, for the next 5 years, probably at least 5 years, there will be two Internet of Contracts. There will be a public blockchain Internet of Contracts, which you're very familiar with. And then there will be a bank Internet of Contracts, which will be separate because it has a separate set of basically legal requirements. And we are in the process of merging these two worlds because both of the worlds are now starting to run on a single messaging system, messaging standard, which is what CCIP is. It's a messaging system to interconnect all of the chains and all of the applications on the chains, both in terms of their value and in terms of their messages. The next stage will be more overlap. So we're now in the early stage of how do you get a few banks to interact with each other about valuable interbank transactions. And we're in the stage of how do DeFi applications interact. But there's actually a third stage of how do you get them to interact with each other. So how do banks use DeFi, and how does DeFi sell stuff to banks? Which, by the way, I don't know if you know this, but banks have a lot of money. A lot. Like a lot more than anyone else in the whole place ever, forever. All the money. They have it. They're banks. So if like we want the industry to grow, we need new money to come in and use the applications. Banks are one of the places that will come from. I don't know how fast it's going to come. Can't make any like promises about that because they have all these legal requirements. But I do know that they're doing transactions with each other, or starting to. And I do know that DeFi will provide greater returns. And so banks are in the business of returns. And if DeFi gives them better returns than they can get from a bank counterparty, some portion of the bank's capital is going to get used in DeFi. Because the choices for them is going to be simple. Do I get 4% from my bank counterparty? Do I get 8% from DeFi? And some percentage of bank capital will say, you know what? I like this DeFi thing. I'm going to get my 8%. And then if we can accelerate that more, two things happen. The first thing that happens is the crypto industry grows. And the second thing that happens is that the distinction between the bank industry and the crypto industry like disappears basically. And it just becomes the global financial system. Like the new global financial system. Right? The new, just like on the internet, there isn't like a bank internet and the internet for us. We're all just on the same internet. And sometimes you can use something a bank has and sometimes you can't. But we're all in the same place, right? And that provides a lot of value. So in addition to whatever's going to happen in the public blockchain world, whatever's going to happen with capital flows from any number of places, I think that getting banks securely and reliably connected into the blockchain world is going to be one of the big next steps for them to have a positive influence on our industry as a whole. And just so you guys understand, banks are there to make money. That's what they want to do. They don't want to do anything else. They don't care about anything else. Money. The whole thing is based on money. Balance sheets, profit and loss statements, bonuses. And so if we can make a reliable industry where they can make money with less risk, and then we can make a reliable way for them to access that technically, then our industry can grow. And as you all know, growth in our industry is a lot of fun. And that would be good. So that's the fundamental outcome from all this, right? In addition to more cryptographic truth, in addition to more reliable things from our industry, in addition to our industry providing more value, right now the industry occupies a space of 1 to 2 trillion. And what we wanted to occupy is a space of everything. All the space. Hundreds of trillions of dollars in value. So we're now at a stage really where in order for this to happen, our industry needs to meet the requirement of users, which is basically the security and reliability that they expect from any system, being the best in our industry. That means we can't have big failures. So we need to build really secure, reliable systems that avoid and manage away big failures. And then we need to create the systems and the rails to connect all the world's value into our industry. And then we can have an industry worth hundreds of trillions of dollars. And that'll be very good for society because that'll be a global financial system powered by cryptographic truth. And it'll be very good for our industry because it'll be worth hundreds of billions, sorry, I'm still getting used to the trillions. Hundreds of trillions of dollars. Great. So hopefully this was helpful. Once again, I'm really excited to be here. We're actively growing our Singapore office and Hong Kong and Korea. And we're going to be building a much bigger team here. And we're going to be working with hopefully some of the biggest banks and other entities here. And very excited to see you here. Thank you for your interest in our work. I hope you enjoy the rest of the event. Thank you very much.